Hello statistics class, my name is Kevin Bernstein and today I will be helping you learn about the confidence interval for a one sample mean. So if you can please flip to page 518 in your book and it'll be problem number 68. So if you need more time, just pause the video and find the problem as quickly as possible. But if you're already there, I will read the problem out loud and then we will go through how to find the confidence interval. A big toe problem. Hallux abductor valgus, called HAV, is a deformation of the big toe that is fairly uncommon in youth and often requires surgery. Doctors used x-rays to measure the angle in degrees of deformity in a random sample of patients under the age of 21 who came to a medical center for surgery to correct HAV. The angle is a measure of the seriousness of the deformity. For these 21 patients, the mean HAV angle was 24.76 degrees, and the standard deviation was 6.34 degrees. A dot plot of the data revealed no outliers or strong skewness. Now that last sentence is very important because we will be using that for a normal condition. And then we will be doing question A, which is construct and interpret a 90% confidence interval for the mean HAV angle in the population of all such patients. So, as you all should know, the first step is state. So when stating, you're kind of reiterating what is said in the question and what we'll be searching. So we will be constructing a 90% confidence interval for the mean HAV angle in the population of all patients with HAV. So make sure when you are writing the first step out that you are very specific with who the population is and with who you will be studying and the sample and what you're actually searching for. So now we will be moving on to step 2, which is the plan. So in step 2, we are searching for the 3 conditions for the confidence interval for one sample mean, which are random, independence, and normal. So for random, it is actually stated in the question, doctors use x-rays to measure the angle in degrees of deformity in a random sample of patients under the age of 21. So you can write down random sample of patients under 21. Condition is met. Okie dokie. And now if we are going on to the independent step, as you should know, there's the 10% rule, which would be multiplying 10 times the amount of people in the study. There are 21 patients who are under the age of 21, and you have to make sure that is less than the amount of people that under 21 that have HAV. Under 21 that have HAV. And what I like doing is writing below the number that we got. And yes, we do not know the actual size of the population, but we can assume that more than 210 people have this issue. So I like writing seems legitimate. And now going on to the normal condition. Because of how this is not a proportion, this is a mean, you will base it off of the CLT theorem. And something very important stated at the end is how, so we know the CLT theorem is not met. The sample size is less than 30. However, because of how so what we would do is because it's greater than or equal to 15, we will check if there's any major skewness. However, there can be no outliers whatsoever. And as you can see in the last sentence, it says, a dot plot of the data reveal no outliers or strong skewness. So we can basically say, we want to state, we will write that because CLT is not met, there can be no major skewness and no outliers. And then afterwards, of course, because the last sentence, condition met. In this case, we do not need to actually draw out a graph because of how they tell you in the problem that the normality condition is met. So now, when moving to the so now we're actually moving on to the doing aspect and actually solving this problem. So the first step is, of course, really writing out the equation. And so this is the third step. Do. So the equation x bar plus or minus t star with the sample standard deviation over the square root of the sample size. If we plug the numbers in, we have 24.76 plus or minus t star, and then we have 6.34 over the square root of 21. And now when we actually get the t star, we first have to find the degrees of freedom, which you always need to show in all your problems, which is the sample size, n minus 1. So in this scenario, it's 21 minus 1, which equals 20. And now if we plug it into a calculator, we can use inverse t, and then we have 0.05 over with 20, and we end up getting the t star value of 1.725. So now we are just finishing up writing this equation correctly, plus or minus 1.725, and then times 6.34 over square root of 21. Now if you plug that all into your calculator, you should get, you should be getting the confidence interval of 22.37 to 27.15. Now, congratulations, you have just found the confidence interval. But hey, not so fast. You're not done. You still have to write the conclusion. And now for probably my least favorite step, but definitely one of the most important ones, is the conclusion. So, I will be typing this one out. We will conclude that we are 90% confident that the true mean HAV angle is captured by the confidence interval 22.37 degrees to 27.15 degrees for the population of under 21 patients with HAV. A great job. You have now completed the confidence interval for a one sample mean. Very exciting. Now go have a lot of fun and enjoy the rest of your day. Thanks.